All right, we got the completing the square method. This is one of my actual favorite methods for completing a square because I can do it mentally pretty quick. So I actually kind of enjoy it. Anyways, first step is to divide everything by a, and a is a 1. Next step is to move your constant to the right-hand side or left-hand side, whatever. It just needs to be away from this. Now what we're going to do is we're going to take half of b, and it's big that you show this stuff. You're going to find b over 2. I'm right here. So that's going to be negative 6 over 2, which is negative 3. I'm right here at step 4. I'm going to square that negative 3, and I'm going to get 9. Now I'm at step 5. I add 9 to both sides to maintain balance. On the right-hand side, I have a negative 4 plus 9, which is 5. Step 6 is to factor the left-hand side. Factors of 9 are 3 and 3. And if they're both negative, negative 3 plus negative 3 is negative 6. If something's written twice, it was squared. As soon as you get b over 2, you know how it factors. You do. All right, so now we're at the stage where it talks about counteracting squaring. You counteract squaring by square rooting. This is a quadratic. It has 2 solutions, so you better include the plus or minus symbol. The 2 on the square root cancels out the 2 on the square, and you have x minus 3 is plus or minus root 5. And then we put this 3 over here. We jump equal, we change signs. We're 3 plus a root of 5, or we're 3 minus root of 5. Now, these two numbers are actually called conjugates. Those are conjugates of each other. They're actually called well, I lost a thought. They're just conjugates. I was going to add more to it, but they're just conjugates. All right, let's move on to, I guess, maybe 4. And on 4, the first thing you have to do is you have to divide everything by a, because a is 2. So x squared plus 4x plus 10 is 0. Now I'm going to jump that 10 over. I leave some space. I'll go off the side. I'm going to take half of b. I'm going to find b over 2, which is 4 over 2, which is 2. And I'm going to take that 2 and I'm going to square it and get 4. And I'm going to add that 4 to both sides. So this one's kind of interesting. The left-hand side factors as x plus 2 times x plus 2, because 2 times 2 is 4, and 2 plus 2 is 4. And the right-hand side is negative 6. If something's written twice, it has been squared. The opposite of squaring is square rooting, because this understood 2 and that 2 cancel out. And we have x plus 2 equals a root of negative 6, which is not real. It's not real. And I'm sure I talked about this in your lesson today, but we have this idea of an imaginary number called I, and it is the root of negative 1. I almost forgot something else. This is a quadratic with 2 solutions. I better have the plus or minus symbol. So when I look at root of negative 6, I think I have a root of 6 times a root of negative 1. And that's what I is defined. So this is I root 6. So x plus 2 equals plus or minus the imaginary root of 6. And then we shift the 2 over. X is negative 2 plus or minus the imaginary root of 6. So negative 2 plus an imaginary root of 6, or negative 2 minus an imaginary root of 6. Believe it or not, you wouldn't have electricity if it weren't for the concept of imaginary numbers. Crazy how we needed something imaginary for things to make sense. It's used in electrical engineering for it's either the amperage or the voltage that is lost when you run through a capacitor. I can't remember. One of the two. I'm not an electrical engineer. And let's see what number 5 looks like. So if you're solving for x, if you're finding your zeros or your x-intercepts, you have to be set equal to 0. We're going to move that 5 on over. It's going to make it positive. I'm kind of glad of that. So this one won't have imaginary solutions. And I think this one factors. Although it's not going to be pretty, is it? So here, and I've got some more work to do. I forgot to do this, so I don't know why I didn't do it. I've got to divide everything by 6. I should have done that first. Forgive me. It doesn't really matter which, the first and second steps can be done out of order. But b is negative 13/6. And you're supposed to find half of that. You do that by throwing a 2 in your denominator, and you get negative 13/12. Okay? Now you're supposed to take that negative 13/12 and square it. Ah, that doesn't sound like much fun. It should be 169 over 144, but I'm pretty sleepy. Don't use decimals. Yeah. You're supposed to add that to both sides. Fun stuff, huh? And now, normally we factor the left-hand side, but we're going to factor the right-hand side. Watch this. I'm not even going to think. As soon as you find half of b, you know how it factors. That's how this technique works. Now we're going to focus on the fraction. You got 169 over 144 plus 5/6. You're going to have to multiply 6 by 24 to turn it into 144. And if you do it to the bottom, you better do it to the top because you learned that in 4th and 5th grade. And 5/24 is 120. And we'll check me just to make sure I'm right because you guys won't believe me. And this is 289 over 144. Crazy, huh? So let's just make sure Milbrath is right. 169 over 144 plus 5/6. Enter. Math, convert to a fraction. I was right. What's even cooler about this is because the next step is to take square roots. It's going to be 17 over 12. And it is. So anyways, this is equal to 289 over 144. The opposite of squaring is the square root symbol, because the 2's cancel. So x minus 13/6 is plus or minus 17/12. And all we got to do is add 13/6 to the other side. 13/6, by the way, is 26/12. We have 26/12 plus or minus 17/12. It actually worked out not too bad. It really didn't. So 26 and 17 should be 43. I have 43/12 or 26 minus 17, 9/12. And these do reduce some. 43 and 12 are both divisible by 6. Are they? No, they're not. They're not. Sorry, forgive me. The 9/12 reduces. That's what, 3/4? I was expecting it to work out a little better than this, but boy, it did not, did it? I must be having a brain fart somewhere. What happens? I just expected the numbers to be a little smaller. I'm gonna pause this for a second and contemplate, make sure I didn't make a mistake. I did make a mistake. Wrong arrow. It's right there. This is on me. Sorry. I knew I made a mistake somewhere because the numbers weren't coming out right. It's this that has to go there. All right. So that should be take away 13/12. That's what I get for not thinking. All right, so that changes things a little bit, but not a whole lot. But I am going to have to start over from here on. Bummer, right? Oops. So this was still going to be 17/12. It's going to be plus or minus. And we're going to have x minus 13/12 over here. We're going to shift our 13/12 over. We'll have 13/12 plus 17/12 or 13/12 minus 17/12. So 13 and 17 is going to make 30, I think. And 30 over 12 is going to reduce down to what? Those divisible by 6, 5/2. Here we're going to have -4/12, which is going to reduce down to -1/3. Now, this will factor. We're going to use our form here, y equals a times x minus p times x minus q. And we're going to plug these things in. A is 6. Y equals 6 times x minus 5/2 times x minus, sorry, not minus, yeah, minus, times x plus 1/3. Isn't this funny looking? It really is. Now, cleaning this up's not too bad. I know that 6 is 2 times 3. Don't you? And I want some cancellations to happen. So I'm going to make this a 2. And then 6 is 2 times 3. Put a 3 there. Distribute my 2 in. I'll have 2x minus 5. Distribute my 3 in. I'll have 3x plus 1. And there's the fully factored form. Sorry I made a mistake and burned up some of your time. How much time have I got anyways? I got a little bit of time. This is factoring practice. I'm going to leave this for you. Here's a quadratic formula. I'll do one of these. You have to do both of these basically the same. Of course, you'll set it equal to 0, and you're also going to do a little factoring. 12 will enter 108 9 times. So I'm going to pull a 9x. That'll leave me with x squared minus 12. Now, this is the thing I have to worry about. It's the thing I'm going to use the quadratic formula on. Probably shouldn't, but we're going to anyways. It's x squared plus no x minus 12. By the way, this guy right here is already telling me that x is a 0. That's one of my solutions. We're going to set up our quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. So opposite of a 0 is just a 0. 0 has no sign. Plus or minus a 0 squared minus 4 times a, which is 1, times c, which is 12. All sitting pretty over twice a, and a was 1. And that is in -12. All right. Inside this radical is going to be a root of 48. And 48 is 16 times 3. So it's 4 root 3. Now this 0 is nothing to worry about. We have plus or minus 4 root 3 over 2, which is plus or minus 2 root 3. So I want to talk about this vocabulary word again. We have a 2 root of 3, and we have a negative 2 root of 3, and these are conjugates. Conjugates. All right, it's done. Funny answer, but it's done. And I'm going to do this one by completing the square, or you know what, I'm going to leave that one for you. I'm going to derive the quadratic formula by completing the square on ax squared plus bx plus c is 0. This is legit where the quadratic formula came from. Because apparently completing the square was just too hard for people. So we had to make it easier, because that's what we do. We just keep dumbing stuff down in society, mathematics included. Anyways, we're going to follow our steps, and the first step is to divide all terms by a. That'll be x squared plus b over ax plus c over a, still equal to 0. Now we're going to move, I thought I changed color there. We're going to move that piece to the left. By the way, let's go ahead and do the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. See how this is already a negative c over a? It's getting there. Give it a few minutes and we'll get there. We are supposed to take half of the b term. We're supposed to find b over 2, and that's this piece right here. Kind of funny, huh? So that would be b over a with a 2 in the bottom. That's what it would be. Then we're supposed to square that piece. And if you square it, you get b squared over 2 times 2 is 4, a times a, 4a squared. And that's the piece you add to both sides. See how we have a b squared? Starting to come together. You're supposed to factor the left-hand side, and that's going to be this thing. Not even going to think about it. And I'm going to do it right this time, as opposed to the last time I did it. That's how the left-hand side factors. I swear that's how it does. Kind of weird, huh? We're going to have to put this together. This is going to be kind of interesting. I'm going to change the order around a little bit. We have b squared over 4a squared minus c over a. And you know as well as I do that if you're going to add fractions together, you're going to have a common denominator. So I need to turn this a into 4a squared. And to do that, I'm going to multiply it by 4a. And if I do it to the denominator, I have to do it to the top. So b squared minus 4ac, both pieces now over 4a squared. Now we're going to take the opposite of a square root by squaring. Is it just me? Look, I'm hitting that change color. Include the plus or minus symbol because we have to have 2 answers. And some of this we can do. I can take the square root of 4a squared. The square root of 4a squared is 2a. Over here, you understood 2 cancels out that 2. And all I got to do is move b over 2a to the other side. In most countries outside America, they actually leave the opposite b over 2a part separate. Why we merge it, I couldn't tell you, but we do. So anyways, there is your complete the square homework. That was fun, wasn't it?